Okay, do you see the entire screen? I'm not sure which I'm sharing at the moment.
Yeah, I'm seeing the full screen.
Okay, perfect. That's great. So thank you for inviting me, and please interrupt me if there is any question, because I think it's very important that you get a good understanding what we are doing, what we are aiming for. So the title is Geroscience 2.0 because Geroscience already exists, and now we have to make sure that Geroscience is being implemented into clinical practice. At least that's my goal. And I'm doing that at the National University of Singapore. So close by to you, if you see how big the world is. And I also worked in the last 10 years in the Netherlands and in Australia. On the right-hand side, you see my contact details. So if you want, please get in touch with me via LinkedIn or Twitter or send me an email. So that's given.
To interrupt you, Professor Mayer. Is this only for practicing, or we're jumping onto the main session?
Oh,
it's just, oh yeah, I'm so sorry. I'm so sorry. I'm so sorry, Professor Mayer. We're not on the opening yet, but we'll surely get to that. Yeah, I'm so sorry. Yeah.
Okay.
Our introductory session is off the schedule, but maybe this is only introductory, not yet until the main session.
Okay.
So currently we're waiting on the participants to join us in the moment. So later I will open the opening first, and then I'll skip that to our moderator. Then you'll have your time.
Yeah, good.
I'm so sorry. I'm so sorry.
Oh, that's all good. It's all good. Okay. I can start over. No problem.
Yes, thank you, Professor Mayer. Okay, maybe for now we're just gonna wait. If you want to do something else first, it's okay. It's definitely okay. And then yeah, thank you very much.
Maybe we still have 8 more minutes, right, Miss Bella?
Yes, we still have 8 minutes to go. So yeah.
So I will get some water. I will be back in a second.
Okay. Okay, then.
Yes.
Thank you.
Yeah.
Putar video lagi. Assalamualaikum warahmatullahi wabarakatuh. Menjadi kebanggaan di Sekolah Pasca Sarjana Universitas Yarsi. Inilah kami, program studi Sains Biomedis.
Universitas Yarsi terletak di jantung kota Jakarta, sehingga mudah diakses dengan berbagai transportasi yang ada.
Magister Sains Biomedis merupakan salah satu program studi Sekolah Pasca Sarjana Universitas Yarsi. Didukung pengalaman lebih dari 50 tahun Universitas Yarsi, dosen-dosen yang berkualitas, serta fasilitas pembelajaran dan penelitian yang lengkap, Magister Sains Biomedis Universitas Yarsi siap menjadi salah satu pusat pendidikan berbasis penelitian strata 2 yang unggul dalam bidang ilmu sains.
Memiliki staf dosen profesional lulusan dalam dan luar negeri.
Program studi biomedik mengembangkan diri dengan melakukan berbagai kegiatan meliputi meningkatkan wawasan dan memperkaya pengalaman riset di bidang keilmuan biomedik dari pakar nasional maupun internasional, membangun database kegiatan Catur Dharma untuk menunjang akreditasi dan audit internal maupun eksternal, serta membangun kerjasama dengan berbagai institusi terkait meliputi perguruan tinggi, lembaga penelitian, industri, lembaga pemerintah dan swasta dalam rangka mengembangkan program Merdeka Belajar.
Di Yarsi, kami mendidik mahasiswa biomedik untuk memahami dan menguasai ilmu-ilmu terbaru dan paling canggih di biomedik, terutama untuk memahami mekanisme penyakit, bagaimana melakukan penelitian, bagaimana proses dan desain dari penelitian dilakukan untuk membuktikan apakah obat yang digunakan itu memiliki efikasi misalnya, atau kita juga berusaha menelaah bagaimana mekanisme terjadinya penyakit dan untuk mencocokkan dengan obat yang tepat. Karena sekarang kita semakin canggih dalam era penelitian genetik, kita tahu mengenai genomic sequencing, ya, kemarin ada hikmah dari COVID sehingga ada penggunaan teknologi next gen sequencing yang terbaru. Dan ini penting untuk membuat kedokteran semakin presisi. Nah, hanya saja di samping menguasai ilmu biomedik yang sangat detail, kami juga ingin para mahasiswa memahami spektrum dan luasnya kajian Islam terkait dengan penggunaan dan penerapan ilmu biomedik atau produk biomedik di masyarakat agar masih sesuai dengan nilai Islam dan tentu dari sisi syariat Islam. Disitulah komitmen kami untuk memastikan para mahasiswa ini juga bisa memahami bahwa Islam sendiri juga memiliki tradisi dalam mencari ilmu pengetahuan yang sangat ketat. Untuk masalah pembuktiannya juga harus benar. Dan ini kita ambil pelajaran dari COVID kemarin. Dan COVID kemarin kita ketahui munculnya kontroversi mengenai vaksin, karena vaksin yang kini di era COVID bisa diselesaikan manusia tahun adalah produk dari rekayasa genetik dari perkembangan biomedik modern.
Kesan selama mengikuti perkuliahan sekitar kurang lebih 1 tahun, saya pribadi merasakan bahwa materi yang kita dapatkan di program Magister Biomedis ini sungguh-sungguh sangat menarik dan kemudian juga menambah wawasan saya serta mendukung dalam profesi yang sedang saya jalani saat ini.
Alhamdulillah saya sudah belajar 1 tahun secara offline di kampus ini karena pandemi, dan selama saya kuliah di sini banyak ilmu baru yang saya dapatkan. Pada prodi Magister Biomed, mereka memiliki sarana penelitian untuk stem cell, herbal, halal, genomik, dan telomer. Dan ilmu ini sangat mendukung saya dalam praktek keseharian saya sebagai dokter estetik dan anti-aging. Di kampus ini saya juga menemukan teman-teman yang baik, teman-teman yang kompak dan saling mendukung, juga dosen-dosen yang berkualitas.
Pandemi telah banyak merubah kehidupan kita. Kita harus menerima kenyataan ini dengan beradaptasi dan menerapkan prokes. Di setiap kesulitan pasti ada jalan. Kami yakin pandemi ini juga membuka peluang baru. Salah satunya adalah peluang untuk belajar. Di Yarsi kami belajar dengan cara yang tidak pernah kami bayangkan sebelumnya, yaitu melalui daring. Yarsi telah membuka kesempatan bagi kami untuk menimba ilmu tanpa batas, mendekatkan ilmu meskipun tetap berada di rumah, bertukar beristirahat dengan berbagai pakar dan berbagai
Assalamualaikum warahmatullahi wabarakatuh. May Allah subhanahu wa ta'ala give us all salvation and blessing. Thanks to Allah subhanahu wa ta'ala because we are still given health favor to be here. May salawat and salam for our Prophet Muhammad sallallahu alaihi wasallam who always give goodness to the world. Good morning, ladies and gentlemen. My name is Belatria Kenshai, student from YRC University. And I'm going to be your master of ceremony for this wonderful and precious chance with the public lecture of Geroscience 2.0 2021 held by YRC University Biomedical Science Master Study Program. Second, let us firstly forward our greetings to the Honorable Postgraduate Program Director of YRC University, Professor Dr. Haji Chandra Yoga Aditama, to our Honorable Speaker for the event, Professor Andrea Meyer, followed by Mr. Erisman SSI MSI and Professor Dr. Haji Jurnalis Udin PAK, to all of the honorable participants, and lastly to the committee of Geroscience 2.0 who made it possible for us to gather today. As your master of ceremony, allow me to read several sequences of our agenda. The first, opening. The second is the recitation of the Holy Quran. The third is singing Mars TRC. The fourth, welcome speech from Postgraduate Program Director of YRC University. The fifth is the main session by our guest lecturer, Professor Andrea Meyer, followed by our speakers from Mr. Erisman, Sarjana Science, Magister Science, Master Science, and Professor Dr. Haji Jurnalis Udin PAK. The seventh is question and answer session, and eighth is closing by the MC. Ladies and gentlemen, step on to the following agenda is recitation of the holy verses of the Quran recited by our sister, Dr. Bunga Indah Kalkausari Pursidi, Master MKes and Master of Law. Time is yours.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Walaqad arsalna Nuhan ila qaumih falabisa fihim alfasanatan illa khamsina aman fa'akhazahu tufan wa hum zalimun فأنجيناه وأصحاب السفينة وجعلناها آية للعالمين وإبراهيم إذ قال لقومه اعبدوا الله واتقوه ذلكم خير لكم إن كنتم تعلمون. Aku berlindung kepada Allah dari godaan syaitan yang terkutuk. Dan sesungguhnya kami telah mengutus Nuh kepada kaumnya. Maka ia tinggal di antara mereka 1000 tahun kurang 50 tahun. Maka mereka ditimpa banjir besar, dan mereka adalah orang-orang yang zalim. Maka kami selamatkan Nuh dan penumpang-penumpang bahtera itu. Dan kami jadikan peristiwa itu pelajaran bagi semua umat manusia. Dan ingatlah Ibrahim ketika dia berkata kepada kaumnya, sembahlah Allah dan bertakwalah kepadanya. Yang demikian itu lebih baik bagimu jika kamu mengetahui. Shadaqallahul azim. Maha benar Allah dengan segala firman-Nya. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much to our sister, Dr. Bunga Indah, Magister Health Management, Master of Law, which recited the Holy Quran. May Allah always give us guidance and help. Amin, amin ya rabbal alamin. The third agenda is singing Mars. The third agenda is a welcome speech from Professor Dr. Haji Chandra Yoga Aditama as Postgraduate Program Director of YRC University to give his insight and warm welcome to the attendees. To Professor Dr. Chandra Yoga Aditama, the time is yours.
Thank you, Bella. So, Assalamualaikum warahmatullahi wabarakatuh. Professor Andrea Meyer, Pak Erisman, Prof. Jurnalis Udin, colleague, ladies and gentlemen. First of all, on behalf of the Postgraduate School, Master of Biomedical Science, Geroscience University, I would like to welcome you all in this morning and thank you for attending our plenary lecture on the very important topic of Geroscience 2.0, the healthy elderly of Indonesia. As I said, this is a very important topic, at least for 3 reasons. Number one, 5.9% or almost 6% of Indonesians are above 65 years old. So there are 16 million in Indonesia on the age above 65 years old, including Prof. Journalist and me, at least, or maybe some other in audience. So that is one reason that why this is important, because it is the problem for the country. The second reason why the topic is important, because based on WHO, that on 2030, 1 of 6 people in the world will be above 60 years old. I just checked yesterday, the WHO said that on 2020, there is about 1 billion people above 60 years old, and on 2030, it will become 1.4 billion. So it's quite a number, of course, and that's why it is important. And the third one, which I think it is one of the most important thing, is because this year, 2021, is kind of beginning of the decade of healthy aging. I think the name is Decade of Healthy Aging, 2020-2030, and it was declared by United Nations General Assembly. So it's clearly, but it is declared by United Nations General Assembly, not by the WHO. So I think maybe Professor Meyer or Pak Erisman or Prof. Journalist can tell us later on why it's not WHO, but I think because this healthy aging issue is not only a health issue, it is a multi-sectoral issue, and it should be, taken care multifaceted or multi-sectorally. So based on these 3 important, not important, but based on the 3 reasons, we are very fortunate that we have Professor Andrea Meyer with us. Professor Meyer is the co-director of Center for Healthy Longevity, National University of Singapore. So Professor Meyer, thank you very much for your kindness to share your knowledge and experience with us. Professor Meyer is very eminent expert in this area. So we will have a very fruitful discussion with her today. And Professor Meyer, I do hope that this plenary lecture or this webinar is kind of a beginning of our further collaboration between YRC University and your institution in the coming future time. We are also very happy to have Pak Erisman with us. Pak Erisman is from the BKKBN. That is, I tried to find it what is the English terminology for it. It looks like it's National Population and Family Planning Board. So Pak Erisman will share with us what is the Indonesian government policy on the healthy aging or elderly in this regard. And last but not least, we will have Professor Journalist Udin. Professor Journalist Udin is he is now a chairman of the YRC Foundation. He is a founding father of YRC University, and he is still the father of YRC University as of now. And he is about, I will not tell you his age, maybe he will tell by himself, but he is about 2 decades more senior than me. I will not say more older, but 2 decades more senior than me, but he is still very active very visionary, and Prof. Junairuddin will show to us how everybody could contribute to the world, to the science, to global community, whatever our age is. So by that one, I will not let's have a interesting discussion. Again, thank you very much, Professor Mayer, Pak Erisman, for joining us. Let's have the fruitful discussion, and let's have get a better understanding of this Geroscience 2.0. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Dr. Haji Chandra Yoga Aditama, for the warm welcome to the attendees, and next on to the following agenda. Before we move on to the main session, I would like to ignite our spirits on getting fired up for the main session. Before that, we're going to sing Marsyarsi. For the operator, please, can you help me? Okay, thank you. Thank you to the operator. And next we move on to the main session. I hope you are ready for the main session, because we're going to move on to the next agenda for Geroscience 2.0, guided by our amazing moderator this morning, Dr. Dwi Vikyasari, SGRC University Biomedical Science Master Study Program student. Good morning, Dr. Dwi. Good morning, Dr. Dwi.
Good morning, Miss Bella.
Okay, how are you today?
Oh, I'm feeling great today. And how are you today, Miss Bella?
Thank you, I'm great. Without further ado, Dr. Dwi Vikyasari, the mic is yours.
Thank you to our MC, Miss Bella Tria, for giving me the screen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Ladies and gentlemen, welcome to this public lectures, Geroscience 2.0, entitled Healthy Elderly of Indonesia. Indonesia is starting to enter the aging population period, where there is an increase in life expectancy followed by an increase in the number of elderly people. The development of longevity medicine enables acceleration from basic science to human research and clinical practice. To discuss this problem, Yarsi University Biomedical Science Master Study Program collaboration with National University of Singapore proudly present public lecture Geroscience 2.0 today, October 26, 2021. First of all, let me introduce myself. My name is Dr. Dwi Fitriasari. It is such a great honor for me as your moderator today. Ladies and gentlemen, please let me to welcome our special guest today. Welcome to the Honorable, our keynote speaker, Professor Andrea Meyer, as the Co-Director Center for Healthy Longevity, National University of Singapore. Welcome to the Honorable Postgraduate Program Director of Yarsi University, Professor Dr. Chandra Yoga Aditama. Welcome to the Honorable Mr. Erisman Sarjana Sains, Master Science, as the Director of Direktorat Bina Ketahanan Lansia dan Rentan BKKBN. Welcome to the Honorable Professor Dr. Jurnalis Udin as the Chairman of Yarsi Foundation. And last but not least, to all audiences, thank you for joining this public lecture, Geroscience 2.0. I'm very pleased to see you here and welcome you to this lecture. Today's panel session is about Lansia Sehat Indonesia, or we call Healthy Elderly of Indonesia. Before we begin the presentation, I would like briefly to read the sequence of the sessions. This lecture is divided into 3 sessions. First is the presentation of the material from our speakers. Second is discussion. This is the Q&A session. We will be open the Q&A session after all the speakers delivered their presentation. And last is conclusion. Before we start the presentation, let me inform all the participants here while hearing the presentation from the speakers. If you have any question, please drop your questions in chat box. Thank you. Now, ladies and gentlemen, without further ado, please allow me to welcome our keynote speaker, Professor Andrea Meyer, to deliver her presentation.
Thank you.
Prof. Meyer, without reducing our respect, we informed you that you have 60 minutes to present the material. To Prof. Meyer, the time is yours.
Thank you. First, I will share my screen that you can also see some slides I brought with me. Give me 1 second. Okay. I think now you see the entire screen with the slide, isn't it? Okay, so that's good, perfect. So thank you once again for inviting me, and I really hope that out of this session we can really see if we can work together more closely together on aging. And as it has been mentioned, aging, I wouldn't say it's a problem, but I think it's a huge opportunity for the next coming 10 to 20 years, how we solve certain issues around in aging society. As mentioned, I work at the National University in Singapore, so close by to you, if you see the entirety of the Earth. I also have an affiliation with Europe, with Amsterdam. I'm working at the Vrije Universiteit in the Netherlands, and recently moved from Australia in Melbourne to Singapore, and I must say I love Singapore. So I'm very glad that we can really build on this relationship. What you're seeing here on the first slide is our center. It's not the entire center, not the entire building, but at least this is the forefront of the building where the Center for Healthy Longevity in Alexandra Hospital is built. And you might think, why is she talking about Geroscience 2.0? First of all, I will introduce Geroscience in a second, but I call it 2.0 because Geroscience is already around for around about 5 to 10 years. But I think as a clinician, I'm an internal medicine specialist and geriatrician by training and seeing lots of patients. I think we have to bring knowledge into clinical practice or bring it into public health. And that's the reason why I called it 2.0, because Geroscience, as it is at the moment, is really focused on animal studies, which is great, but lacks yet the clinical implications. So that's the reason why it's 2.0. So What is geroscience? Geroscience is really the understanding of why we age, what's happening during the aging process, and how aging is interfering with age-related diseases. And bringing all that expertise together, that's the aim of geroscience, to do that. So what do we do at the center? What's dear to my heart? And that's 4 pillars. I'm talking today about roughly 4 pillars of research. And I hopefully will convince you that these should be the main pillars of research in the next coming years, and also the implementation. First of all, we are working on the understanding of disease clusters. As you might know, is that if you progress to a certain age, it's very likely that you have a disease, but it's most likely that you have 2 or more diseases. So one disease is never coming alone. I shouldn't say never, because yes, of course, sometimes it happens, but most of the times we have clusters of diseases. And I will show you some evidence in a second. Then the second pillar is we need clinical biomarkers. We need to measure how somebody is aging in clinical practice, so in GP practices, general practitioner practices, but also in the hospital and maybe even in the community. And I depicted here a couple of these kind of measures, which are quite easy to implement in clinical practice now. And that's, for example, measuring cognition. So not asking somebody, do you think that your cognition, your memory is good, but really testing it with screening tools. I think we should really measure, for example, muscle strength, because muscle strength is very important for the aging process. And there are a couple of tests doing that. So for example, sitting to standing, if somebody can't do that, that's already a sign that muscle strength is not well. Hand grip strength is one of them, and you see in the slide a handheld dynamometer. But also measuring, for example, blood pressure continuously, or measuring blood pressure is very important. And something like measuring body compositions is very important, I would say. And also, for example, and that's a little bit more fancy, with calorimetry or indirect calorimetry, how much energy somebody is using. But I think we shouldn't forget that we should also ask and maybe also test if not only the mental and the physical capacity is good, but also the social embedding. And that's the reason why I brought the picture of a dog. So it's not about that dog, but it's about the social integration. And I think we should ask and we should check, because lots of my patients say that they are socially integrated. However, they are not really, if you check it. So that's a clinical biomarkers. Another thing is the biological biomarkers. I think we are in a time where we now understand what biological biomarkers could bring. And one of the biological biomarkers could, for example, be C-reactive protein. It's a very easy measurement. We can measure everywhere on Earth. It's a measure for inflammation. But if you track that during lifetime, it could already be meaningful. But of course, we also have clocks where we look at how aging is really progressing. And there are lots of other biomarkers now in the pipeline. And I think these should be used together with clinical biomarkers to really see the picture. And of course, measuring is one thing, but intervening is another. So I really think that we have to work towards geroscience interventions. So the intervention of, for example, implementing lifestyle to move more, eat less, don't smoke, etc. So that's very important. However, I think we are now at a stage where we can use, for example, drugs, repurposed drugs to make somebody younger. And I will come back to that at the end of my talk. First of all, is we have to look a little bit what's occurring during the last, I would say, 50 to 60 years, and why is aging now a topic, whereas in the 50s of the last century, it was not a topic. And here you see the life expectancy of men during lifetime from the 50s to around about 2010. And what you can see is a couple of things. First of all, I would like to draw your attention to the yellow curve, which means that you are seeing the male life expectancy at birth and saying when the majority of males would die in the 50s. And that was round about in their 50s or 40s at that age, and round about 60. And since then, what you're seeing is that the variation in when people die really narrowed down to, if you look at the graph in 2010, it's really narrow. So the time when we are dying is really different. And we are nearly dying, not at the same time point, but in the same decades of life. And that's in the 60s to the 80s, the majority die. Or what you can also see that there's a shift to the right-hand side, which means we are growing older together and we are dying in certain decades of life. Why is that? So why is there a shift towards a higher life expectancy? This is because we have a very safe environment, or we build safe environments. So we have regulation and rules for everything, at least here in Singapore. So life is not dangerous anymore, or it's much less dangerous compared to 60 years ago. We also have hospitals. Here you see myself in a white coat, and next to that is my husband while I was still working in the Netherlands. So he is a hospital manager and I was a doctor at that point in time. So we really built worldwide an environment of healthcare systems which are working very well. And we have lots of research, and therewith we have lots of capacity to make somebody either younger, but the sickest less sick. So we try to cure all the diseases. And there has been, since I was in medical school, a huge number of medications being built I had never heard of in medical studies. So there is really a revolution that if we are sick, we can be healthy again, or at least we can live with the disease. And that, of course, then leads to a population change. And here you see by the United Nations, the demographic changes we are facing at the age of 60 and 80. So what is the population at the age of 60 and 80, and how is that growing? And what you can see is that it's growing in every continent. So aging is not specific to Asia. It's not specific to Europe. The entire world is aging very, very fast. But what you can see, please excuse, what you can see is that the yellow one is really Asia, where there is a huge amount of 60 plus individuals and 80 plus individuals. And of course, I wouldn't say this is a problem, but this is the success. So I think we should congratulate ourselves at this moment in time, living here, that actually we grow older quite gracefully, hopefully. And as a society, we just have to now deal with it, and hopefully we will find solutions how to age in health. I would like to show you a couple of slides just demonstrating how we are aging, so populations worldwide. And I would like to draw your attention to, for example, cognition, which is very important for healthy aging, that you can think, that there is memory. And here you see the mini mental state examination. So this is a screening test to measure global cognition and what's happening during lifetime. So on the horizontal axis, you see the age of individuals. On the vertical axis, you see the MMSE, so a measure for global cognition. And you see on all the dotted lines are all longitudinal studies, where people were measured longitudinally at least for a couple of years to see what the change is in MMSE, and then over lifetime. And every of these dots is another longitudinal study. So this is the entire evidence on Earth until 2020, because this is a systematic review. And what you see is that the line is dropping at the age of round about 70 to 80, where actually our cognition, with the very, very easy global test, we see that a couple of individuals, lots of individuals are going to fail to make it, because the green line is the cutoff point for the MMSE, which is 24. So if you are below that cutoff point, we would think about, okay, this is not a good cognition anymore, and you might think about more measurements to exclude that somebody has dementia. And what you can see is, and that's depicted in red, there's lots of populations from the age of 65, 60 onwards, which are already below the cutoff point. So this is occurring while we are aging. And what kind of risk factors do we have, for example, for dementia? And we included hundreds, thousands of individuals in this kind of study we published in 2019. So what are the risk factors for a really bad cognition? And that's, for example, hypertension, diabetes, myocardial infarction, heart failure, stroke, atrial fibrillation, etc. All these risk factors we try to adapt in clinical practice are also the risk factors for dementia, and therewith the risk factors for not aging healthily. So this is the reason why we cannot just talk, okay, let's improve cognition. No, we have to make sure that our blood pressure in the population is down, that the glucose level is down, that the lipid levels are okay, and then we do not have a stroke, a myocardial infarction, heart infarct, and atrial fibrillation, for example. So the human body is quite complex. So trying to cure one disease might not help. And that's also the reason why we have lots of multimorbidity. Here you see the graph just showing that the number of multimorbid individuals are increasing during lifetime. And roughly, I always use at the age of 60, 60% have comorbidity, so at least 2 or more chronic diseases. At the age of 70, 70% have more than 2 chronic diseases, etc., and 80%. So it's very frequent. So with age, we are attracted to lots of these age-related diseases. And I would like to show you that now we can predict who's getting a disease and what kind of disease is following, because this is very important. Because if there are GPs, for example, general practitioners, and they have an individual with, for example, a heart disease, what is the likelihood that that person also gets another disease or is going to die? So can we already predict what's happening in the future to prepare our healthcare system better? So that's the question. And a colleague of mine published that in Nature Communications in 2020, asking that question in a Swedish cohort of individuals who were accumulating diseases. And I will talk you through. First of all, he looked at the outcome death, because if you are dead, you cannot have another disease. So that's very important. And he looked at specific disease clusters, and he defined them as heart disease, psychiatric disease, eye disease and cancer, cognitive and sensory impairment, and respiratory and musculoskeletal diseases. And the rest of the population, he couldn't really cluster. So that's the unspecified. And he then asked himself, okay, if you have cognitive impairment and sensory impairment, so for example, a bad vision and cognitive impairment, what's the likelihood to have another disease? And what you see, the likelihood is very big that that person is going to die. So if you have at around about the age of 75 in Sweden, cognitive impairment and sensory impairment, it's very likely that you are going to die. However, there is a big proportion which is not going to die to have then respiratory diseases or neuropsychiatric diseases. So which means that neurologists talking about dementia should maybe talk a couple of times to their colleagues in the lung field to actually see, okay, how can we prevent respiratory disease? I will give you another example. People with heart disease, very likely that they are going to die, and we know that. However, people with heart disease are very likely to get cognitive impairment. So because your blood pressure most of the times is low when you have heart disease, and therewith cognitive impairment will occur because your blood is not going to, not the pressure is enough to go to the brain, or the blood pressure is too high, and therewith people are at risk of stroke. So if somebody has heart disease, it's very likely that these individuals also will have dementia in a couple of years' time. And in this study, it was 6 years' time. If there's heart disease, it's also very likely that that person will have cardiometabolic disease, for example, diabetes, and then 12 years later. And of course, the propensity, the likelihood of dying is also much higher. So now we can, just giving you these examples, already we can predict what's going to happen in the near future. So how do we identify the individuals who are at risk for either dying or to be have a higher biological age, so be a bit older and having risk for disease? And I like this picture of Saudek. That's a famous photographer and artist who just made a photo of his mom and showing the mom at the age of, I think, 75, with a picture at the age of 40. So, and really showing that it's very beautiful how you age, but how identify, can we identify individuals who can age like this lady? And first of all, it's important that we disentangle who is aging normally and who is aging faster and who is aging slower. So that's very important. So because you and me, we will age differently, and you and your colleague will age differently. So there are fast agers and there are slow agers. And at very high age, it's very easy to actually detect who is a fast ager and a slow ager. And that's depicted in this figure. Most importantly, if we are looking at these individuals, we really have to disentangle chronological age from biological age. So both ladies are 80 or 70, doesn't really matter, but you see phenotypic differences. So, and what clinicians are doing, if they are looking at these individuals, you're looking at what is somebody doing? What's the environment? What is the hair color? How is the hair dressed? What is the shape of the face? How many wrinkles does somebody have? How is somebody standing? Is somebody sitting? Does the environment already show where somebody is? And what is the gesture? So how likely is it that that person is going to walk? And what likelihood is that that person is going to talk? And what likelihood is there that that person has a social environment? And there is clinical practice, but also in research, we always define the biological age based on 3 factors. And the 3 factors is cognition. So can somebody talk, and can somebody remember? The second thing is, can somebody walk? So what is the muscle strength? What's the ability to function physically? And then what is the social environment? And I think you can clearly see that there's a huge difference between these 2 individuals. We can also identify, because it's very easy at the age of 80, but what about at the age of 60? Can we predict who is going to decline and who will be dependent on, for example, activities of daily living? We did lots of research in the past years to actually see if we can identify young seniors who are at risk for detrimental outcome. And the detrimental outcome we defined as activities of daily living's decline at the age of 60 to 70. And what we did, we took lots of cohort studies, which you see in the right-hand corner. So the Enchianti study in Italy, and the LASA study in the Netherlands, and a German active on study, and the ELSAR study in UK, where we looked at, okay, can we identify factors which are predictive for functional decline at that age in males and in females? And what we found is that there is a proportion of individuals who will have functional limitations in 10 years follow-up time. On the left-hand side, you see the 60 to 70-year-old males, and you see that 9.7% have a severe limitation in their activities of daily living in 10 years' time, whereas this is 6.9% of really decline in functional performance or functional limitations. And there is a group of around about 1/3 of the population, with the 30.9 and 36.8 for males and for females, who also decline. But there is, I think, the chance to intervene. So we can detect individuals with a likelihood which is quite high to detect individuals who will have a decline in their activities of daily living. And that's this group. There are also around about the half of the individuals who do not decline. So as a physician, I would say, why should I then bother? So why should I invest in them? So if I would have a shortage of resources, I would actually invest in the ones who are going to decline, because then with interventions, you can make a life better, perhaps. And making a life more healthier is also the aim of the geroscience hypothesis of the geroscience field, and that's extending the health span and diminishing the time with disease, and that's depicted here. So the normal situation, that's the upper line. So we have until our 50th birthday, depends on the country, sometimes even 40, we live with health, and then we have lots of age-related diseases. So we would like to have an optimal longevity and a very short period with disease and a little bit of life extension. So the aim is not to reach the age of 1,000 or 5,000 or 10,000 years. That's not the aim. The aim is to be longer on Earth with health. And there was also be productive, for example, and be a workforce, which is very important. And to do that, we needed a code and we needed a disease, because I'm a physician. So if I don't have a disease, I cannot treat something. So that's the reason why lots of us lobbied a lot to recognize aging as a disease. And that might be counterintuitive, because I think lots of us will say aging is normal. And yes, chronological time is normal, so the time is ticking at this moment in time. But the consequence of that time and how your body is reacting, that's very important. And that's, if that's abnormal, could be a disease. So in 2019, and now it was published already 2018, there were the first publication that World Health Organization added a code, actually 2 codes for age and age-related differences, a sort of biological age, to the International Classification of Diseases. So that's very important, because now we can interact already at younger ages, for example, at the age of 25, to interfere with the aging process, because it's now recognized as a disease. If you haven't heard of geroscience and you haven't heard of that ICD-10 code, of 11 code, that doesn't really matter, because we are really in the youngest phases of geroscience, because it's a very young field. And I would urge you to read that this paper in the BMJ, really showing that geroscience is coming of age and really highlighting there is a lack of knowledge. However, we think we can fill that gap, and hopefully we can fill that together. But there's a huge opportunity, because if we are tackling aging and we can age gracefully and we can intervene, then we might increase our health. So the entire idea is, don't wait until somebody has heart failure. Don't wait until somebody has diabetes. Don't wait until there's a stroke, but detect the individuals at higher risk and intervene much earlier. So can we intervene? Yes, we can, because we know why we age. This is depicted here. You see here the mechanisms of aging. On the left-hand side, you see the fundamental ones, so the biological ones. And on the right-hand side, we merge that a little bit also with clinical phenotypes. Let's go first to the left-hand side. So there are 9 hallmarks of aging. So, and there are lots of unknowns. That's the reason why there is a 10th circle in that circle. And the major ones, I would say, is nutrient sensing. So how can a body handle glucose, for example, in food? Loss of proteostasis is very important. These 2 are very important in terms of interventions at the moment. But there's also cellular senescence, which is a cellular state where a cell is not dividing anymore. The cell is in the tissue and is not undergoing apoptosis, which is the programmed cell death, but interfering quite negatively with the environment. So cellular senescence seems to be not good. It might be good at earlier age, but not at older age. Another one is telomere attrition. So at the end of the chromosomes, there are telomeres and they are getting shorter, and therewith it might be that a cell is not dividing anymore. There is epigenetic alteration, which is very important. So you have genes, and on top of the genes, there are layers. and genes can actually be methylated. And dependent of what that layer is, genes can be regulated differently and can be pushed on or off. So, and we know now that lifestyle, for example, can interfere with epigenetic regulation. And therewith, dependent on your lifestyle, you can put your genes into action, or you can say stop, which is, I think, very powerful. And on the right-hand side, we have to use the biological, I would say, assessment very nicely. So the molecular phenotype, and link that to the clinical phenotype, to diseases, but also to function. And we have to take the lifestyle into account, which is very important because that's interfering with the aging process. I would like to convince you that cellular senescence is really important, and it might be a very nice marker also for biological age. And you might have heard of Hayflick. He is depicted here in his 40s, 50s. And then I saw him in Sydney a couple of years ago, 90 plus. So he is still there, and he was the one who actually saw the first time that cells cannot divide indefinitely. So he really created the field of cellular senescence. And on the right-hand side, you see a skin biopsy and from a human being. And what you see is on the upper side, is the upper layer of the skin, and then the lower layer of the skin. All the blue dots are cells, normal cells, and everything what's brown is a P16 positive cell, and that's a senescent cell. So brown is no good. But what you really can see is that, for example, in this skin biopsy, senescence is quite clearly present. So the question is, where do senescent cells accumulate in the human being? And I can tell you everywhere. In my body, in your body, in everybody's body. Nobody is really escaping senescence, I would say, or at least I haven't found that individual yet. Here you see a summary of all the rich literature until 2020 out of our lab, where we looked at, okay, are senescent cells accumulating over time in different organ systems? And in which organ system do we find senescent cells most? On the horizontal layer, you see all the organs. You see an eye, you see vessels, you see blood, you see a brain, blah, 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 blah. Lots of organs. On the vertical axis, you see the association. If senescent cells are more highly present in these organs at a higher age, yes? So which means that if the bars are up, that means that there is more senescence, much more senescence at older age. And what you can clearly see is actually that there is one organ, and that's the brain, but there's also another organ, and that's the pancreas, which is a little bit more on the right-hand side. And you see that the bars are quite high, which means that the association is much stronger in the brain, in the pancreas, compared to the other organs in the relation of senescence and age, which means that the senescence load in the brain and the pancreas is much higher with age. So why is that important? Because the brain and the pancreas get lots of diseases. So the brain will lead to dementia and the pancreas will lead to diabetes. So the organs which are much attracted to age-related diseases also have much more of senescent cells accumulating during lifetime. So being much higher at the age of 50, 60, and 70 compared to a 20-year-old. Senescence is also associated, for example, how somebody is look like. We did lots of studies where we made photographs of aging individuals at the age of from 40 to around about 80. And from these individuals where we had photographs, we judged their age with a panel and also computer-based. And we also investigated how much wrinkles somebody has and how somebody looks like. And then we took skin biopsies from these individuals from the inner upper arm. So really from the inner upper arm, because that's a region where there's no sun exposure most of the time. So there where cells are not stressed by sun. And then we looked at, okay, for example, how much wrinkles somebody has, is that associated with the number of senescent cells in the inner upper arm? And yes, it is. And it's also associated how somebody is being judged. what the perceived age is. So you can judge myself being 30, then I would thank you. I'm not 30. But if you have the idea that my perceived age is 30, then it would be more likely that I have a lower number of senescent cells. So the perceived age is associated with how cells are doing in our body. And senescence is also associated with age-related diseases, and that's our recent study recently published, where we looked at lots of organ systems, and we looked at, for example, the brain, and we looked at lots of senescence markers, which are given vertically. And what we did is we compared individuals with, for example, cognitive impairment of dementia to controls of the same age. Or you are controlling, or you are looking at people with heart failure being 60 to people with the same sex not having heart failure. And what we actually showed is that independent of the disease we are looking at, and everything which is depicted in blue is significant in going into the right direction, everything which is red is not significant, and gray is a little bit, we don't know. But what you see, everything nearly is blue, which means there's a positive association between senescent cells and disease, which means that if we are looking at individuals with dementia, there are much more senescent cells. They are also accumulating with chronological age, but even then, there are much more in, for example, in the brain, much more in the heart, much more in the liver, much more in the kidney. So senescent cells are not only associated with how somebody looks like, but also with age and with disease. Of course, you might think, okay, we cannot implement measuring senescent cells, and I fully agree in clinical practice. So what we did is we compared in a cohort of 60-year-olds, we compared a couple of functional capacity measures versus molecular level measures, and how good they were in predicting either chronological age or biological age. And we defined biological age as having diseases. So we took from a very big cohort data from the hand grip strength, so it's muscle strength, 4-meter walk test, chair stand test, and lots of cognitive tests. And we compared the predictive capacity to a CRP or a senescence marker or an immunological marker, how differentiated the immune system is. And what we were able to find is that the clinical markers are much more predictive for chronological age and biological age compared to all biological markers. So clinically, it's very useful to measure hand grip strength. It's very useful to measure gait speed. It's very useful to measure all these things, and don't measure yet in clinical practice all the other stuff I told you. Because it's much more meaningful and it's much easier to do. And I think we have to sort out in which individuals do we need these more molecular markers, and in what individuals do we need more clinical markers. So, but in the end, we can identify individuals at certain ages, what their biological age is. So I would like to spend the last 25 minutes to really talk about interventions. And interventions are dear to my heart because I think we are measuring a lot. And if we are just measuring, we are not changing something. And I would like to change something because in the end, it's not about knowing that you are much older compared to your passport chronological age, but to make you younger or to make you better and to prevent something. And this is very important picture because this picture is really highlighting that our cells are interfering with what we are doing and really interfering with lifestyle. So a hypercaloric diet, for example, will make you more attracted that your telomeres will be shorter. If you have a hypercaloric diet, it's more likely that you also have epigenetic changes and no good epigenetic changes. If somebody is sedentary, it's also highly associated, for example, with stem cell function or replication of cells. We have, I would say, lots of environmental challenges, pollution, for example, and the pollution is also interfering with what our cells are doing. And that's very important to take into account because somebody can be very active, But if you're living in a big city with lots of pollution, I'm even not sure if you make it worse. So we have to work together with policymakers to get the entire picture and not just telling people lose weight and be physically more active. And we also have, of course, to make sure that the diet we are eating is adequate. So we need vitamin D, we need the macronutrients and the micronutrients, which are essential to build our body. So lack of healthy nutrients is, I think, also a big challenge. I would like to convince you that we can change it, because here you see that by a very easy experiment, we can show that individuals are going to be healthier, or at least their cells are. And I called it Cells Love Movement. And what they did is around about 60 healthy individuals of the age of 50, 55, being quite sedentary. They were put on a treadmill for a couple of sessions per week, for a couple of weeks, and they took blood at time 0, so 0 months, 3 months, and 6 months. And while having that treadmill walking and running, they looked at how is the telomeres and telomerase activity and the senescence markers, how do they change? And the upper level A is telomere length. And what you see at 6 months, there's a much higher telomere length in people who were on the treadmill. If you look at telomerase activity, which is the enzyme making telomeres longer again, you see it's up. And P16 is the senescence marker, which means that if it's lower, that's good, because there are less senescent cells, which is nice. Physical activity is very important. We just published, or will come out I think tomorrow or today, a paper in Lancet, Healthy Longevity, where we summarize the entire literature of really everything what's measured when you're using an accelerometer or a step count. So devices who objectively measure the movement of human beings. And that can be depicted, and that's on the upper row, by steps, by counts, activity counts, by total physical activity, that's TPA, or MVPA is the mid to vigorous physical activity, LPA is low physical activity, and SB is sedentary behavior. On the vertical axis, you see all the outcome parameters: mortality, activities of daily living, frailty, falls, muscle strength, and global cognition. So we looked at all these outcome parameters and we asked the question, can sedentary behavior, is there an association with all these outcome parameters? On the left-hand side, you see all the reviews we wrote. And out of all the reviews, we published an umbrella review, taking all this information account. And this is the summary of it. So this is it. And what you see is, if you see a darker color on a larger circle, that means that the association is the strongest. So look at the bigger circles, which are dark. And there you see the best association of certain activities with certain outcomes. And what you can clearly see is that steps is associated with frailty. You see that large circle, and you also see that steps is associated with lower body muscle strength in the chair stand test, and also with global cognition, which means that every step somebody is taken is lowering the chance of being frail. Every step being taken is increasing the capacity of the lower body to have muscle strength, is improving the chair stand test, and is improving cognition. There is less evidence, if you are looking to the right, to sedentary behavior, that sedentary behavior is really associated with something, because all the circles are either quite very tiny and they are not dark, which means that it's most important that people have steps. It's not so much important the time somebody is spending on the couch, yes, or lying or sitting. Which also means that I'm quite happy if you are sitting at the moment, because this is increasing your sedentary behavior, if you have some steps after this session. That's most important. And when you're doing it, I wouldn't care, but it's most important that you are doing it. So a walk at night, because we are both on both sides, we are living in a climate where it's sometimes hard to be physically active. I know that. It doesn't matter in the morning, in the afternoon, you don't have it at lunchtime, but steps count. And it doesn't really matter how much steps, but every step counts. So it's not really important that there are 10,000 steps, for example, as advised by the WHO. And that's also the reason why this article will be published with the title, Every Step Counts. So there's lots of evidence. And of course, it has to be quite funny, I would say. So let's do a couple of silly walks. And we did lots of studies in Europe where we introduced silly walks into the behavior of individuals. Because normally we think about going into the gym and doing some exercise. And I went there yesterday and my muscles are hurting. Look, I don't have that experience every day because I don't have the capacity to do it. I don't want to do it. But it's most important that what we are doing is a little bit funny and that we enjoy it. And I think while growing up, we don't enjoy physical activity as much as we did when we were kids. If you see kids are jumping around on the street, but you don't see individuals, adults anymore jumping around. And I think we have to learn how we are jumping around or do activities to use our entire body. And that's also the reason why we did studies with individuals in Europe and lots of countries where we introduced squats, for example. We introduced while brushing your teeth. So normally we will brush our teeth 2 or 3 times, depending on your habits. And we normally just brush our teeth all the time. And that's so boring. Brushing the teeth. So couldn't you then do physical activities? So what we introduced was lots of individuals, we asked them to brush the teeth on one leg. Yes. So maybe you can also do that tonight. While brushing your teeth, stand on one leg because you will increase your balance and also your muscle strength while doing so. And it doesn't cost any time and you don't have to go to the gym. But most importantly, and everybody is excited to look at medication, of course. Are there pills to make us younger? And hopefully we don't look like this lady because it's just too young for the age, I would say. But of course, this is a dream. And hopefully this will never happen because hopefully we will also do physical activity and we will eat less. And then we have a pill. What's most exciting, I would say, in the field at the moment are repurposed drugs, and which means that we make use of drugs which are already available and just use them to try to make somebody younger. And why do we want to use repurposed drugs is because we have them available. Think about metformin. That's the drug to lower the glucose level and being given to diabetic patients. So they're available, we know how they work, they're safe, and they're cheap. So that's very important. So it has to be cheap in the end because everybody is suffering from aging, everybody here in the room. If you want or not, because the time is ticking, it has to be a very safe profile because we don't want to introduce any side effects and we don't want to introduce harm. And one of the big studies you might know is by Nia Basile, a dear colleague of mine in US, who is giving metformin, so the drug for diabetics, in 65 to 80-year-olds who do not have diabetes and who have a very normal glucose level. And why is Nia doing that and lots of others in the world? Because metformin, we know how it works, and it makes your mitochondria in your cell and all the energy balance makes it better. So it's not only just for the glucose level, but it's about how the engine of cells are working. And therewith, it's expected that after 6 years of these 3,000 individuals, they have a lower chance of having cancer, cardiovascular disease, dementia, and also a lower chance of dying. He is at the moment doing that in 60 to 80-year-olds. And I would say, I love the idea, I love the study, but I think it's much too late because already at the age of 60, there's so much damage that we should start earlier. We should start at the age of 20. At the moment here in Singapore, we are starting at the age of 40. Because at the age of 40, individuals already have their children, they're settled, you have the job, and then they are investing more in themselves. Whereas at the age of 20, life is very, very difficult, I would say, and different, because you're creating your family, you have to find a job, you go to university, or you are so busy with creating and managing your life. And at the age of 40, you are stabilized. So then you can really invest in yourself. So that's the reason why in Singapore here, we are really investing in individuals who are 40 or 50, but much younger than, for example, Professor Barzilai is doing. And what kind of evidence do we have that repurposed drugs might help? I brought you a systematic review and the evidence of how to prevent cognitive decline in individuals. Here you see all the evidence until 2018, where we looked at proteostasis modifying drugs, and I will explain proteostasis. So if a cell needs a protein to make, then the cell will just make a protein. And during lifetime and while aging, the proteins are misformed. Like packaging the proteins is malfunctioning. It's not going well. So in the end, you get products which have a lower quality and would not go through the quality check normally. But at higher age, the folding of proteins is disturbed. And that's the reason why medication who might help with the packaging of the proteins might decrease the likelihood that somebody is going to be sick. And we just look at cognition as one of the outcomes because there's lots of evidence. And what you can see is, for example, lots of medications like lithium, rapamycin, or methylene blue, they're all evidence that these drugs, that they can improve proteostasis in animals. And that's what you see on the left-hand side. Everything what's green is positive. Everything what's black is negative in terms of trial. And the X's, these are trials ongoing. And what you can see, there's lots of green, and especially lithium of rapamycin, there are lots of studies. And looking at cognition at the endpoint, showing that we can change it. And that we can change it in and improve it, for example, in animal models. We also looked at nutrient-sensing drugs to improve cognition. And here you see, for example, all the anti-diabetic medication like metformin or insulin, but you can see also growth hormone or GLP-1 agonists, which are a little bit, they came into the market like 5 years ago. You have also SSRIs, which is against depression, statins, and they all interfere how our cells are sensing nutrients and how they go along with glucose and everything we are eating. And making that more smoother means that also our cells might have less damage and therewith might have the potential to prevent age-related diseases, for example, dementia. And what you can see is everything in green is positive, the trial. Orange is a trend towards something good, and negative is red. And you see the species in the species column. There are lots of mice and rat studies. There's not much really or there's a little bit in human. But what you can see, most of the studies in humans are red. So it's not positive, it doesn't work. However, if you're looking in detail in these studies, there are also some, for example, in intranasal insulin, there are also green ones. And depending on how you select the individuals, you might have a green or red result. Because it's very important that we include individuals with the chance of improvement. Most of the times, these studies included the healthiest of the healthiest. How can you improve a healthiest of the healthiest, making them healthier? And that's a huge bias. So that's the reason why we have to look at individuals with a chance of decline in the near future to prevent that. So we have to select our individuals a little bit more carefully. Another example, to just go to the natural products to improve, just as an example, cognition, but healthy aging, is factors like glycogen synthase kinase 3 inhibitors. So these are compounds who might improve cognition via in axis. I won't go into detail depicted here. So GSK3 is very important to prevent, for example, Alzheimer's disease and the accumulation of amyloid beta. So it's very important to have that part of this physiology right. And for example, we searched lots of literature, and what we found is, for example, the curcumin or sea cucumber of the bee pollen from coffee flowers have all the ingredients to interfere in this pathway. So, and we looked at, or lychee, for example, the lychee seeds. So are these ingredients, might they improve cognition? And we looked at all the literature, and what we were only able to find is animal studies. So there's no human study yet, but we are going to do some here in Singapore. And everything what's encircled in green is positive. And what you can see, if you give these kind of natural or synthetic products, GSK3 inhibitors, then most of the times the ones who are published in mice and in rats, etc., they show a positive effect, which is quite nice, of course, and that's what we would like to see. However, there's also a couple who are negative, which is given in orange, and there is a couple who are negative, of course, but the majority is positive and is green. So I think hopefully I convinced you that we not only can identify individuals, and at the moment we can identify individuals by just looking at blood pressure, glucose levels, gait speed, and all the things we're already doing in clinical practice. However, we should do that really longitudinally and at much earlier ages to detect the individuals who might be at risk of decline. And once we detected the individuals at risk for decline, we don't have to wait. We have interventions in place, and that's a proper lifestyle, which is a very powerful pill if we do it right. So, and if we test if it works, because if we don't test it, then people will not really interfering with what we say, because they want to be better. So they also want to have the answer. So powerful is already the lifestyle. We are really now in the area where we can repurpose drugs, which we're also doing here. And there are lots of natural compounds we can test to, in the end, really build Geroscience 2.0. And that really means we have lots of ideas already in animal studies, but it's really the time to do that in human beings. And of course, there should always be studies in animal models, but I think we have so much evidence that we can now process to do it in ourselves. And don't be scared to do it in humans, because it's not rocket science what we would do. And it's also very important that we reach out, I would say, to the general public, that you and me and everybody here in the room make this talk of the town, that everybody knows, yes, aging will occur eventually, absolutely. We cannot, I think, stop aging, and we don't have to live, and I don't want to live until 10,000 years. But what we can do is that we can age gracefully and really try to prevent age-related diseases while getting things sorted, measuring what we are doing, and intervening very likely. And the public, I would say, needs to know that. So hopefully you will spread the word with me. Thank you.
Well, thank you to Prof. Meyer for giving such an interesting knowledge here for us. Wait a minute. Vision here. There's something that I skipped just now, Prof. Meyer. Please apologize me. Thank you very much for Prof. Meyer for giving us such informative and interesting presentation. Before we step into the next speaker, please allow me to read out Professor Andrea Mayer curriculum vitae. Herewith I will read. Name Andrea Brita Mayer, Professor, Dr., MD, PhD, FR, ACP. Current position, 2021, onward on Chusung, Professor in Medicine and Functional Aging, Co-Director, Center for Healthy Longevity, National University of Singapore. Academic qualification, 2003 license to practice medicine, Medical University Lubek D, magna cum laude, University of Lubek 2003, doctorate integrated care of elderly suffering from medical and physiatric disease, Medical University of Lubek D, magna cum laude. On 2008, PhD cellular senescence in vitro and organismal aging, LUMC Netherlands. On 2009, specialist internal medicine and geriatrics, Royal Dutch Medical Association, Netherlands. 2018, fellowship, the Royal Australian College of Physicians, Australia. Professional awards, 2009, Dutch Association on Internal Medicine Award. 2014, Clinical Nutrition Award, ESPEN, Geneva, Switzerland. 2018, Excellence in Medicine Award, 2018, Melbourne Health, Australia. 2020, elected member of the Royal Holland Society of Science and Humanities. 5 most important publications that pertains the proposed project is targeting impaired nutrient sensing with repurposed therapeutics to prevent or treat age-related cognitive decline and dementia. And then repurposing proteostasis, modifying drugs to prevent or treat age-related dementia. Association of brain pathology, cognitive and physical markers with age in cognitively normal individuals at 60 until 102 years. What determines cognitive functioning in oldest old? And then age dependency of risk factor for cognitive decline. Thank you. And then, ladies and gentlemen, let's move on to the next speaker, Mr. Erisman, Sarjana Science, Master of Science. Herewith I will read out Mr. Erisman curriculum vitae. He is a Director of Resilience Development of Elderly in Vulnerable Families BKKBN. Currently active promoting the National Strategy for Sustainability Perpres nomor 88 tahun 2021. Contribute to and be concerned with elderly health programs, various activities to achieve strong, healthy, active, productive, and dignified elderly programs that are proclaimed in the BKKBN. Now, without further ado, Mr. Erisman, Sarjana Science, Master of Science, you have 15 minutes to deliver the presentation. Well, Mr. Erisman, the time is yours.
Thank you, Mrs. Dwi.
Dwi.
Yes, thank you, Professor Myers and other speakers. My response to this presentation is very good, very good, and clearly and very interesting.
Thank you.
Actually, I'm not the medicine, I'm not medicine, but amount of us duty is regulation of elderly. Gen science is very new for me because the professor explained to us much thing about this. the main important thing maybe how to live long life for us. Yeah. Aim of Geroscience is to give a long life. We have explained from Professor Mayer to improve cognition and nutrition, drug juga, and then lifestyle. Yeah. It's very important, but all of presentation by research is very good ya, by research ya. Yeah, not only speaker tapi but only by research, based on research, explaining based on research. By the way, maybe I explain the other side ya. Maybe my file can be shared ya, Mr. Salma. Okay. Maybe the other side ya. But my Professor Mayer is very important ya. But Geroscience is this is a little bit explanation for us, for Indonesian, about healthy aging ya. Next. Yeah, Miss Professor Mayer also explain to us about the lifestyle ya, siklus hidup from embryo until death ya, janin, bayi, anaknya. Yeah, this approach for good lifestyle. Next. The regulation more in Indonesia for aging ya. Undang-Undang nomor 13 tahun 98 about sosial lanjut usia. Undang-Undang nomor 52 tahun 2009 tentang perkembangan improving population and quality of family. Undang-Undang nomor 23 tentang pemerintah desa. This pemerintahan government of daerah. PP nomor 87 tahun 2014 about the improving the population and quality of family. And the new one is purpose number 88 tahun 2021 about strategi national of aging ya. We have priority, we have program, we have activities and a project to aging in RPJM. Next. In Stranas 88, we have 5 strategy about aging. The first is peningkatan perlindungan sosial, the second peningkatan derajat kesehatan and quality masyarakat dan lingkungan ramah lanjut usia. And the fourth, penguatan kelembagaan pelaksanaan program lanjut usia. The five, penghormatan, perlindungan, dan pemulihan hak lanjut usia. We have aging, penyakit yang shock, demensia, kanker, Alzheimer, heart disease, and diabetes. Next. Professor Mayer, this is our population aging here. Female and female in Indonesia. We have 226 more million in Indonesia in 2020, but about almost aging population 2020. Next. Yeah, we have then we have 4 quadrants to identify Lansia, aging, elderly, divided the healthy and the economic condition. We have yang that's helpful 10% more. Ya, ada 4 kuadran. Yang pertama dari pendekatan kesehatan dan kondisi ekonomi ya, yang 40% ke bawah ya. Jadi yang perlu perhatian yang merah ini, 10% ya. That is termasuk intervention Geroscience. Next. Sama. We know that Mr. Professor Mayer explained to us maybe there are 2 factors for elderly people. That is individual factor and environmental factor. Individual factor consists of lifestyle, change of age, genetica, and disease. And environment factor is housing, technology, transportation, maybe social facility. That is from expert for gerontology. Next. Now we have M for Geroscience is long life. Yeah. I think the same. Yeah. I think the same. We hope aging people. We have health and mandiri, active, productive. That is dan bermartabat, smart. We call that smart. Yeah. And next. Next, Pak Salma. We have age, family function, the same 7 dementia, lansia tangguh, aging population, active aging, ya, fungsi agama, sosial budaya, actually the same about to the age function of family. Fungsi keluarga agama, fungsi sosial budaya, fungsi perlindungan, fungsi kasih, fungsi reproduksi, fungsi sosial, fungsi ekonomi, dan fungsi pembinaan lingkungan. Sama dengan 7 dimension of lansia tangguh. Next. Yeah, that's all. I will respond the other side. Yeah, but Professor Mayer very clear. But only more in medicine. Maybe I hope we can understand that situation. Thank you the presentation, Professor. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Well, thank you very much, Mr. Erisman, for the good presentations here. I love BKKB and tagline, sir. Berencana itu keren. From the explanation you gave just now, I'm quite sure we can highly understand what factors that affect the health of elderly nowadays. And now we are jumping to the next speaker. The last but not least, our third speaker is Professor Dr. Journalist Udin. Herewith, I will read out Prof. Journalist curriculum vitae. He has a long record of extraordinary achievements, experiences, and activities, but we summarize them as follows. He is a chairman of the YARSI Foundation, Board of Directors, General Chairperson of the Indonesian Higher Education Organizing Alliance, APERTI, Chairman of the Health and Syara Advisory Council, MPKS, Ministry of Health, Republik Indonesia, Professor of Anatomy, Faculty of Medicine, YARSI University, Head of Center for Studies and Gender, YARSI University, Advisor Indonesia Islamic Medical Association, IIMA, and Advisor Federation Islamic Medical Association, FIMA. And now, without further ado, to Prof. Journalist, you have 15 minutes to presenting the materials. To Prof. Journalist, the time is yours. Thank you. You're still unmuted, Prof. Can you unmute the microphone, please? You're still muted. For the team, can we help us to unmute Prof. Journalist?
No, already unmute.
Thank you.
Can you hear me?
Yes, yes, Prof. Yes, Prof. I can hear you clearly. Thank you.
Okay, and then I want to share screen.
Saya sudah agak bunyi suaranya ini. Sebenarnya mau bicara belum bisa bunyi dia rupanya.
Semangat ya.
Bingungan deh.
Sorry.
Omah yang mungkin.
Dwi, can you open my file from your side?
Yes, sir. I will try to help you. Or my team will help you to open the presentation. Excuse me, Prof. We already have your PowerPoint here.
Okay, open it. Open it. Not yet, eh?
Excuse me, Prof.
Not yet. Not yet.
Be open.
Okay. Okay, now open.
We already your PowerPoint here, Prof.
Okay. Thank you, Dwi.
Okay, thank you, Prof. You're welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, la hawla quwwata illa billah. Asyhadu an la ilaha illallah la syarika lah wa asyhadu anna Muhammadan rasulullah nabiyya ba'dah. Thank you very much for giving us detailed information on aging by Professor Maye and Pak Isman. I intend to provide information of what is the profile of elderly in Indonesia. I'm not going to offer what has been done by our government or the society, but it is fully profile of elderly in Indonesia. Next, please. First, I think it is very important for us to define what is elderly. In Indonesia, we call elderly is those who age is 60 and over. In developed countries like United States of America, elderly is those who is 65 and over. This definition is very important because if we intend to compare the situation in Indonesia and other countries, we have to be reminded that definition of elderly is different with other countries. And the other thing is, what is the life expectancy?
Kegiatan 0,5. Bapak Ibu berperan serta aktif dalam pertemuan ilmiah.
Excuse me, for all the participants, we can mute the microphone, please.
And I can see my slide doing.
Yes, Prof.
What happened to my slide?
Can you see it, Prof, now?
Not yet, not yet.
Not yet? Wait a minute, Prof. Just let me have.
Okay, no. Okay. So what is the life expectancy after birth? Indonesia in 1961, we have 47 years. And now in 2019, the life expectancy is 72. Comparing to USA, 79, Australia, Canada, 83. It is also related, strongly related with Italy. Next, please. What is the distribution of elderly based on gender? We can see here that in national population, the elderly is 9.6%. They say almost 25 or 26 million. Bali, 11.3%. We can call it aging population because more than 10%. Yogyakarta, 14.5%. It is also aging population, more than 10%. But Jakarta is only 7.8%. So it is still a long time to go to the aging population in Jakarta. And in general, we can see here that the green color and orange color. The green is female, and the other color is male. We see here that number of female elderly is more than male elderly. Next, please. Next. Okay. So what are the population distribution based on age and expenditure group? The expenditure we define to three: top 20%, middle 40%, and bottom 40%. The elderly population at both national and state provinces is dominated by cohort 8 between 60 to 96. That is 63.82%, 70 to 79 years old, 27%, and 80 and over is 8.5%. Next, please. What will be the elderly distribution based on expenditure group? Once again, in terms of expenditure, The elderly at National Bali and Yogyakarta are predominantly in the bottom 40%, so it is very poor, while the elderly in Jakarta belong to middle 40% and top 20%. So in Jakarta, they are more prosperous than in the region like Bali and Yogyakarta. Next, please. And then, what will be distribution of elderly based on number of household members? At the national level, 6.3% of the elderly in the bottom 40% live by themselves. They live alone. This is very important because they need physical strength improvement. They need health improvement because their health is deteriorating. And they need also mental and social abilities support. So they need company because they live alone, and they need social and family support. Next, please. What is the rate of elderly poverty? The rate of elderly poverty is 11.1%, female elderly 11.8%, male elderly is 10.3%. The poverty rate is 9.4%. So there, yeah, we can imagine that the poverty among the elderly is also very danger. Next, please. What about the literacy rate among the elderly? The literacy rate of male elderly is higher than that of female elderly, but in national and district, both in the national and the three provinces. Yeah, we can see the figure. Next, please. What is the level of education for elderly? Elderly from the richest 20% have the highest average years of schooling. Education level of male elderly is higher than that of female elderly, regardless of the province and income level. Women elderly who had higher degree of education usually came from families with a better socioeconomic condition. You know, we can understand that the poor, the elderly, the less education they have. Next, please. What is the elderly activities in the most recent week? The elderly are often considered a burden to household members who are in productive economic activities. The dependency ratio of the elderly to productive people is 15%. That means 15 elderly people had their life supported by 100 productive people. If the number of elderly increase, the burden shared by productive people will be bigger. That's not good. Next, please. What's the proportion of working elderly by gender? Elderly has to work due to economic requirement to fulfill their basic need. The working elderly in Indonesia are quite vulnerable economically because they still have to deal with economic fluctuation, especially the pandemic. Next, please. And what's the level of education of the working elderly? At the national level, the proportion of elderly working male is 64.5%, while elderly woman is only 35.7%. And then majority of male working elderly who have a low level of education never been to school, or not finished elementary school, or just finished elementary school. So the education is very low. And the elderly with higher education can enjoy better life. The less educated elderly suffers many kinds of economic and societal aspects. So how to improve education among the people is the key word to solve this problem. Next, please. And what is the occupation status of the elderly? The professionals settled in each region is mainly entrepreneurships. So they work by their own. They have their own company. National level, 67.16%. 1/2 of the elderly are full-time workers who are working 35 hours or more in a week. Some even more than 48 hours in a week. At the national level, more than 1/2 of the working elderly work in agriculture, like in Yogyakarta and Bali. Jakarta is urban. They have only very small agriculture. And then there's no significant gender difference between elderly men and women in every business field. Next, please. And what is the proportion of elderly working in informal sector? More than 80% of the elderly work in informal sector. In Jakarta, the figure is 61%. More elderly women tend to be informal sector than elderly men. At national level, elderly women is 89%, while elderly men is 81%. It goes also in Jakarta and Bali and Yogyakarta. Next, please. And what is the working hours of elderly who work? Exactly 1/2 of the elderly are full-time workers, 35 hours a week or more. And in Jakarta, some 34% of the elderly work excessive hours. Next, please. And what is the working elderly by economic sector? At national level, more than 1/2, 52.9% of the working elderly work in agriculture. 84.4% of the working elderly in Jakarta work in the service sector. There's no significant gender difference between men and women elderly. Next, please. What is the average income per month for elderly? In rupiah, this is in rupiah, not in US dollar. The highest average income for elderly are received by those who are working in service sector in Jakarta, so in the urban areas. Those who work in agriculture receive lowest income. Next, please. And what is the health condition of the elderly? There is no significant difference in the rate of health problems and illnesses among the elderly across expenditure groups. 1/2 of the elderly from the bottom 40% have health complaints in Jakarta and Bali. Next, please. And what is the health condition of elderly by expenditure group? In Yogyakarta, the highest rate of health problems and illnesses is in the top 20% expenditure, while the highest of health condition is in the middle 40%. Next, please. And then access for the elderly to health facilities. Recipient of social assistance in Jakarta and Bali have a better possibility to access health facilities, outpatient and inpatient. While in Yogyakarta, the elderly who are not in the receipt of social assistance have better access to outpatient service only, not inpatient, but all the outpatient service only. Next, please. And then the elderly from the bottom 40% will have a better access to health facilities if they have a jaminan kesehatan health plan. It can be seen in the national level Jakarta, Yogyakarta, and Bali. Next, please. And what is this disability condition by age cohort? Disability condition is common among the elderly. Over 1/2 of people in the category of very old elderly over 80 years of age living with disability. The older the group, the more likely they are living with a severe disability. So they need support from the community and the family. Next, please. Next. So what is disability condition of the elderly by gender? In relation to gender, elderly women are more likely to experience functional disorder than elderly men. Nearly 1 out of 2, 48.1%, elderly women have a functional disorder, while elderly men, the figure is 2 out of 5, 41.2%. Next, please. Disability condition of elderly by expenditure group. The highest prevalence of elderly with disability is found in the bottom 40% by expenditure group. In Jakarta, the highest of elderly with disability is found in the middle 40% by expenditure group. Next, please. And then living status of the elderly. We can see here male living alone, female living alone. Male 40.98%, female 13.39%. Living spouse, male 25.28, and female is 15.25. And then living with family, male 32.25, female 22.79. And living with the with 3 generation, And then we can see here male 36% and female 44.8%. And then we can see the aspect in the Jakarta, Yogyakarta, and Bali. Next, please. So, what is the pattern of expenditure in the bottom 40% by age cohort? Okay. Expenditure pattern of elderly in the bottom 40% group, more than half of their expenditure is used for buying consumable food. So this group is vulnerable for food price hikes. They cannot afford, if they get sick, they cannot go to the hospital because if not, they don't have health insurance. Next, please. Okay, that's all. Thank you very much.
Thank you very much, Prof. Journalist. Thank you for the presentation. It makes us more understand about the elderly in Indonesia. Thank you. And now we are stepping to the next session, which is discussion. In this session, we would like to have some questions from the participants. I remind you once again to the participants who are willing to ask a question. For those who want to ask directly to the speaker, please use the raise hand feature in Zoom. Or also you can write your questions in chat box. Each question will be answered directly by the speakers. Wow, it turns out that the participants were very interested in what you have presented, Prof. Mayor. We received so many questions here, and I will read out the one by one. Are you ready, Prof. Mayor?
Sure.
Well, okay then. Well, ladies and gentlemen, now I already have some questions here. The first one is coming from Pak Harliansa. Pak Harliansa is one of our lecturer here, Prof. Mayor, our lecturer in Yarsi University. The question is, what strategic steps need to be taken to deal with aging problems in the industrial era 4.0? Thank you. Do you will answer it directly, Prof?
Yes, I think first we need to agree on what the problem is, because maybe there is no problem, and then you will have to find a strategy. So, and it might be that there is a problem because healthcare costs are too much, or there might be a problem that there are housing issues, or there might be a problem that we are leaning too much on carers, for example, because it's very normal if your parents are sick, I would say, to also care for them. So I think first we need really a societal discussion, what we want to solve first. And once they have that, we can work towards the solutions, I think, which are very important. Look, from a perspective of longevity, I would say we have to make sure that our children and younger adults, that they have a good lifestyle to prevent age-related diseases 20 or 30 years later. And I think that's most important at the moment.
Okay, thank you. And now we are stepping to the next question from Neti Suharti. Also for Prof. Mayor here. There are some plants have anti-aging and antioxidants activity. What's strategic for this issue, Prof?
So if the question is what can we do with anti-aging drugs, first of all, we have to be very realistic. They will not make us live 20 years longer, not the ones we have at the moment. But I think what's most important that we first start with good diet habits. So really overcoming overweight is, I think, the best recipe at the moment, and making sure that if we are eating less, we have the right ingredients. So having, for example, vitamin D on an adequate level is very important. Having amino acids like leucine in our diet is very important. And so these are the steps everybody can take already. And then, of course, there are herbs and there are ingredients like alpha-ketoglutarate and everything else we are testing at the moment, which can be an add-on. If you want to make a societal change now, then make sure that the population has a BMI not higher than 22, and the food is of a good quality, making sure that vitamins are provided.
What do you think between vitamin D and amino acids? Which one is the most important, Prof?
I would say, look, vitamin D. At the moment, we know that, but proteins are also very important. But the vitamin D is a very easy fix. So that's the reason why I'm prioritizing that. We have to make sure not only that in our food we have enough vitamin D, but also if we take it via the food, that our skin gets exposure to sun. So that's very important because we need active vitamin D. If that's not possible, so either because there are also lots of individuals here in Singapore who don't like the sun because the sun can also be dangerous, then we just have to make sure that we supplement vitamin D. Because normally we need our skin to be exposed. So that's very important.
So vitamin D is very important, Prof. So thank you for the answer. And now we are going to the third question is from Mr. Chatur Putro. Also for Prof. Meyer. Based on your experience, what are the different challenges for geroscience in developed countries compared to developing countries, and what is the biggest challenge? Thank you.
Look, the biggest challenge at the moment is to have evidence that it works. It's no problem. There is so much evidence that if a tiny worm, which is called C. elegans, that we can treat the worm or a fly or rat and make the fly or the rat or the C. elegans to live much longer. We know that this tiny worm, C. elegans, can live 4 times longer. We know that mice can live 2 to 3 times longer if we treat them with anti-aging drugs. Now we have to make sure, and that's the biggest challenge in geroscience, that it works with humans. In all the animal studies, we showed that it works in other animals. So why shouldn't it work with Homo sapiens, with humans? So I think this is the biggest challenge. If we then see what's the challenge of developing worlds where there's developed, I think there are huge challenges in both, because I think both are really struggling with lifestyle changes, which are not really good for healthy longevity. So in both of these worlds, we have to make sure that our BMI is low, our body mass index. I think that the appropriateness of food is very important in the developing countries. And I think that the majority of junk food being eaten in developed countries, but also in developing countries, that just has to be reduced. That's not good for us. We are not made to go to McDonald's. So don't do it.
But I love McDonald's so much, Prof. But thank you for the answer. And now we're stepping to the for a question is also to Prof. Meyer from Dr. Diniwati Mutar. As Prof. Andrea mentioned before, metformin can be useful to delay aging. In what age do we have to start, although our blood glucose is normal?
Yeah, that's a very good question. So there have been experiments with a couple of hundreds of individuals at the age of 40 onwards, and that helps. So it's not really about the glucose level, but it's making the energy consumption more efficient in cells. And that's what metformin is also doing. It's not only interfering with glucose levels. And the good thing with metformin, that if the glucose level is normal, it doesn't lower really much the glucose level. So you will not have a very low glucose level and therewith faint, for example. So the idea is, and the big trial is now in 60 plus individuals, but the entire field thinks that from the age of 40, it would be good to take metformin already to be able to prevent the damage. But that has to be proven in big studies, but smaller studies have already that evidence.
Okay, thank you. Thank you very much, Prof. Mayor. Thank you for the knowledge and thank you for the answer. And now we also have another question for Mr. Erisman. Mr. Erisman, can you hear me?
Yes.
Mr.
Yes.
Erisman, saya akan bacakan soalnya dalam bahasa Indonesia. Apakah ada program digital untuk lansia mendapatkan informasi kesehatan yang bebas hoax, mengingat lansia memiliki keterbatasan mobilitas dan penggunaan gadget, agar lansia dapat mengakses informasi, konsultasi, pengobatan, dan kebutuhan lansia agar tangguh, sehat, dan bahagia. Bagaimana ini, Pak?
Ya, sebetulnya ada ya, namanya Golantang, menuju lansia tangguh.
Baik.
Itu platformnya pakai mobile dan website ya, masih mobile dan website, Android mobilenya. Tinggal di-download di Play Store. Golantang itu bisa lihat macam-macam. Malah bisa ngukur kondisi kesehatan lansia. Itu aja.
Berarti Golantang aplikasinya ya, Pak ya?
Namanya Golantang ya.
Golantang ya.
Masyarakat bisa buka ya.
Baik, baik. Itu di Android, di App Store, di Play Store ada?
Di Android.
Di Android.
Ya.
Oh, baik, baik, baik. Terima kasih banyak Pak atas jawabannya. Kami juga memiliki pertanyaan untuk Prof. Jurnalis. Dengan meningkatnya angka persentase lansia di Indonesia dari tahun ke tahun, strategi apa yang dapat dipromosikan untuk membahagiakan lansia agar tetap dapat berdampingan dengan populasi milenial, Prof? Mohon jawabannya, Prof. Terima kasih.
I'm sorry, I think I don't have answer for that. That's the duty of the government, not me. So
it's the government.
Yeah, that's right. Because mostly of the elderly are poor. They are coming from the 40% the lowest group. So I think they cannot afford by themselves to improve their own condition. And then even to fulfill the basic need, it is a big problem for them. Not only the big cities, but also in the rural areas. So I don't have an answer for that. Maybe Prof. Mayor could answer that.
Well, okay. Thank you, Prof. Jurnalis. To Prof. Mayor, can you explain for us?
You have to translate the question first.
Well, okay.
I couldn't really understand the question.
Okay.
Because it was in Indonesia.
Yes, yes, yes. Just a moment. Until wait for the. With the increasing percentage of the elderly in Indonesia from year to year, what strategies can be promoted to make the elderly happy so that they can coexist with the millennial population, Prof?
So the question is how to make older individuals happy?
Yes. Like
look, I'm not the expert. I'm quite an expert and privately to be happy. But I think it's about the surrounding you are living in, and there's lots of evidence that independent of disease, you have at older age, if you were happy or a positive person at younger ages, that it's very likely independent of diseases you have, that you're also happy older at age. So it's a little bit, I wouldn't say that happiness is in your genes, but especially if you are happy as a child in early adulthood, during adulthood, then you will not lose it. So it's a little bit also a trait. And this is also associated how much quality of life somebody judges their life. And the quality of life is not per se just associated with income, for example, or with diseases, but it's more how you're embedded socially also in your surroundings. So people who have friends give a better quality of life, and they say, yes, I have a happier life, and that's independent really of age. So have friends.
Like that. Well, okay, thank you.
Or good colleagues, that's also fine.
Good colleagues, right, sir? And then now we have participants who have raised his hand here. We have Mr. Ahmad Rusdan Utomo, PhD. You can unmute, Pak Ahmad.
Yes. Yes. Yeah. Okay.
Ahmad, time is yours.
Yes. Thank you, Dr. Dwi. Thank you, Dr. Maya, for a nice talk. Maybe a short comment and a question for you. I'm a molecular biologist teaching cancer genetics here in the RC, and regarding your issue about doing research in human beings, I think the obvious challenge is about doing that intervention in aging. Obviously, it's time. It's going to take 2 or 3 generations of postdocs and grad students, and probably they're kind of averse to do long time research, and they probably never get graduate on time. That's probably the challenge, I guess, regarding time. But a question regarding the predictive markers, because you mentioned, if I'm not mistaken, you said that the clinical assessment seems to be more accurate and reliable than the molecular markers. Maybe because there's not specific, because you mentioned a lot about P16 and also telomerase activity and telomere length. But these are actually happens in all cells. So I'm not sure when you mentioned about cognitive impairment, are you measuring the telomere or telomerase activities and also P16 in the whole blood, in the leukocytes, or you're actually doing some neural biopsies? I mean, how would you actually explain that? Is it something, is it useful to do this kind of molecular testings at the moment to have some sort of evaluation? And also, can it reverse it? So for instance, if you say you have loss of P16 probably in the tissues, and then you do some intervention and you see the loss of P16, does it mean that you actually successfully reversed it? Or it is actually a better marker as the so-called the young markers. So instead of the aging markers, you have this youngest marker, if you will. So what do you think about that, Dr. Meyer? Thank you. Take the answer offline.
Yeah, lots of questions. So first of all, why do we find in our big data sets that the biological markers are less good compared to the clinical markers? I think we can explain that quite well, because if you look at hierarchies, first something has to happen in our cells that will translate to organ function, and that will translate to physical function. So if we are capturing physical function, we are capturing a very high level, and that higher level is very likely associated with outcome, either with just our age, how we are functioning, or with mortality or diseases, because it's representative of so many different things going along in our body, which means that it's a quite specific marker, because if we are measuring, for example, walking speed, then it can be, if the walking speed is low, that either there's a problem in our muscles, or there's a problem in our coordination, or there's a problem cognitively that somebody doesn't understand what's going on. So it's walking speed is a very nice marker of overall organ function. And therewith, it's much powerful for associations with bad outcome. I think that's a reason. If you then go deeper and say, okay, on cellular level, if we have different organ tissues, for example, out of muscle, measuring their biological age, measuring in blood the biological age, and get some tissues everywhere, we are really already deep down, and these organs might not be representative for the function, and there was the risk. it's very good to get a better understanding of what's happening in terms of causality if we take all the biopsies and measuring how much stress was there. Is there more senescence? Is there more an epigenetic problem? Is there more a telomere problem? Is there a stem cell exhaustion? So really digging down to reach the causality, what to do. Because, and that's very important if we are going to interventions, I need to know why the walking speed is low. So I need to know if it's a sarcopenia muscle problem, or is a coordination problem, or is there a pain problem because of the joint, or is there a cognitive problem. So gait speed will not help me further to design an intervention for that individual. And then I think the biological markers kick in, that once the gait speed is low, that I can understand why that is in different tissue systems. So should I give, for example, and I haven't touched on that, but should I give a senolytic to try to get rid of senescent cells of that tissue? Or should I try to bring lithium in to get the proteostasis better, so make proteins better in that? So what's the real problem of that individual with a slower walking speed? And of course, it's just one example, the walking speed, but we can do arterial stiffness or other details in the human body we can measure. And I don't think that we will come up with interventions where we say one size fits all, because that will not be possible. Because I myself might have a telomere problem, whereas somebody else in the room might have a mitochondrial problem, and somebody else has a epigenetic problem. And even within the body, I think we showed, at least for senescence, that the accumulation of senescent cells are quite different in different organ systems, which means that if I would have a telomere problem, that might be only applicable for my heart, my lungs might have a mitochondrial problem, or there's an epigenetic problem in my liver because my liver was exposed to some toxins. So I think what we don't know yet is how different organ systems within one individual are aging to solve the problem, and not the problem in terms of even intervention, but first we have to measure it in terms of biomarkers, and then we can find interventions. And we don't know yet if the organ systems age differently and have different mechanisms within individuals. Absolutely between individuals, but we don't know within individuals. I think that's the next challenge, to have individualized, personalized interventions in the end.
Pak Ahmad, is the questions very helpful, the answers?
Right. So I guess this will be another challenge, because usually when it comes to measuring the biological markers, definitely peripheral blood is the most convenient way, but may not be the right way, I suppose.
Yes.
Because because I guess, yeah, it's probably because we cannot just plug our brain and see what kind of telomere activity is going on over there. But it's going to be, I guess, it's still a long shot.
Yeah,
all right.
I think the first thing is really using blood of lots of individuals to learn from it and link that to function, which we can measure easily in different organ systems at the first step. And then really try and also with imaging techniques. For example, there are a couple of traces now where we try to trace senescent cells in the human body. And it's very challenging, but we try it to really see where senescent cells in vivo, thus in human bodies, occur. And I think that would help if we would have also imaging markers and we don't have to take all the biopsies. But that's future.
Right. Okay, thank you, Dr. Meyer. Thank you very much.
Thank you very much, Prof. Meyer, for the answer. I think we have one more question here. Pertanyaan untuk Pak Erisman, I will read it in Indonesia. Mengenai program dan kegiatan prioritas untuk lansia di Indonesia, apa saja yang sudah dijalankan untuk menunjang kesejahteraan para lansia, Pak? Terima kasih.
Program yang sudah dijalankan ya itu ya adanya BKL ya, Bina Ketahanan Keluarga Lansia, yang materinya ada materi 7 dimensi lansia tangguh dan PJP, pendampingan perawatan jangka panjang. Kemudian juga untuk pendalaman kita akan membentuk ya namanya sekolah lansia. Belum lagi kementerian lain juga ada juga yang buat juga. Di Bina Keluarga Lansia dan itu materinya 7 dimensi lansia tangguh dan PJP. Kemudian juga ada penanganan pralansia. Kita utamanya KIE, pendampingan sampai dengan rujukan. Selebihnya mungkin kementerian lain, seperti misalnya charity pada Kemensos ya, perawatan pada Kemenkes dan lain-lain. Mungkin itu. Terima kasih.
Baik, berarti nanti akan ada perencanaan untuk sekolah lansia gitu ya Pak ya?
Ya, sekolah lansia rencananya tahun sekarang udah ada sebetulnya di Jogja, di Jawa Barat, di DKI. Tapi rencananya tahun depan ada minimal 9 provinsi ya.
Oh, yang sudah berjalan berarti kita ada di 3 provinsi ya Pak ya?
3 provinsi ada.
Baik, terima kasih.
Ini 7 dimensi lansia tangguh.
Baik, terima kasih banyak Pak Erisman atas jawabannya. It looks like we have no more questions here. And due to the time limit, I think the discussion session is enough. Thank you to all the questioners. Ladies and gentlemen, we finally come to the end of the panel session. Before I close this panel, I would like to take the conclusion from what the speakers has presented. Research pillars of aging is understanding of disease cluster, clinical biomarkers, biological biomarkers, geroscience intervention year by year, lifespan is narrowing. The entire population starts aging by global cognition research. Cognition starts to drop at the age of 70 to 80. Risk factor, not only age, but multiple risks like blood pressure and so more. 70% have comorbidity at the age of 70, and so on increasing. With age, we engage to relate age diseases. Multimorbidity trajectories, slow, average, and fast age. Chronological is now biological age identify factor proportion with the functional limitations up to 10 years. The aim of Geroscience make life better by extending lifespan. Senescence do affect to us. Senescence association much stronger in brain and pancreas. With age, brain and pancreas leads to disease like dementia and diabetes. There are much senescent cell are not affect somebody. Looks, but also age-related diseases, intervention, lifestyle change matter for better every step being taken reduce frailty. Maintain global cognition, muscle strength and muscle power, learn and jumping around. Do something fun with your activity. Finally, we come to the end of the session, Prof. I would like to apologize to the people who asked, and I cannot handle one by one due to the time limits. And I would like to thank you to our speakers for sharing their knowledge here today. And on behalf of YRC University and on behalf of all attendees, please let me give our highly appreciation to our speaker, Professor Andrea Meyer, Mr. Erisman Sarjana Science, Master Science, and Professor Dr. Journalist Udin for the precious time and the precious knowledge that given to us here. And here in this time, we're from YRC University, we're presenting a virtual certificate appreciation to our speaker. Without prejudice to respect, we ask the speaker to open the camera while receiving the virtual certificate. The first virtual certificate appreciation we give to Professor Andrea Meyer. This is your certificate, Prof. Thank you for participating and the knowledge that you give to us here. We hope.
Sorry. Thank you so much. It was a pleasure working with you.
Yes, you're welcome, Prof. We hope the relation between ERC University and National University of Singapore will be continue and strengthen each other university. Thank you very much, Prof. Mayor, for your time. The second virtual certificate appreciation we give to Mr. Erisman, Sarjana Science, Master Science. Thank you for participating and for supporting this lecture, Mr. Erisman.
Thank you so much.
We hope you keep healthy and BKKBN always goes forward. Thank you, Mr. Erisman.
Thank you.
And then the third certificate is for Professor Dr. Jurnalis Udin. Yes, Prof, this is your certificate, Prof.
Oh, thank you, thank you.
Thank you, Prof, for the knowledge, and also thank you for supporting all the activities carried out, especially by ERC University Biomedical Science Master Study Program.
Okay.
Thank you very much, and also thank you all to all the participants here for the very active participation. Hopefully, the information that we have shared today will be useful for all of us. And I will pass the session back to our MC. Thank you for your kind attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. And stay healthy. Miss Bella, the screen is yours.
Yes, Assalamualaikum warahmatullahi wabarakatuh. Thank you, our moderator, Dr. Dwi Fitiasari. The honorable ladies and gentlemen, it is very nice to see you again after our main session. I hope you have been enjoying yourself with the lecture, followed by presentation and discussion session. May what we have conducted today will be useful for us. Next, we will take some pictures. So to everyone, you can turn on your camera, and please to our operator to lead the documentation. Maybe I will help by saying 1, 2, 3 and smile. Okay, can everyone turn on their camera so we can have some documentation for the event? Untuk teman-teman yang off cam, boleh di on cam kan terlebih dahulu. Kita akan mengambil foto bersama. Oke, baik, kita tunggu sampai hitungan kelima mungkin ya. 1, kita tunggu teman-temannya dulu. Oke, 1, 2, 3, 4, 5. Baik, sepertinya tidak ada lagi yang ingin ingin on cam. Baik, untuk teman-teman operator boleh diambil gambarnya. 1, 2, 3, cheese. Oke. 1, 2, 1. Oke. Dokter Salam, boleh tolong di-unmute? Oke. Oke, one more time maybe. Oke. 1, 2, 3, cheese. Okay. Thank you for everyone. Okay. Next, let us individually, based on our own religion, pray. So you may start to pray now. Alhamdulillahirrahmanirrahim. Pray time is over. I'm very honored to have you here this morning, but now I'm sad to say that we will close the Geroscience 2.0 2021. But don't worry, we may have Geroscience 3.0 and more. So stay updated by following ERC University social media for more information ahead. You can also find us in Instagram. Thank you to all parties involved in this event. Thank you, Professor Andrea Meyer, Mr. Erisman, Sarjana Science, Master of Science, Professor Dr. Haji Jurnalis Udin as our speaker. And of course, and thank you to Dr. Dwi Fitiasari as our moderator, and of course our amazing attendees today. From the deepest of my heart, I apologize for any mistakes in guiding this event. I'm Bella Triakensyai as your Master of Ceremony, saying goodbye to you all, and thank you very much for your attention. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih.
Terima kasih Pak Erisman, Prof.
Terima
Jurnalis.
kasih Pak Erisman, Prof. Jurnalis, Prof.
Nice.
Mayor.
Thank you, Pak.
Thank you very much.
Thanks very much, Prof. Mayor.
Thank you. Thank you.
Profesor.
Ada Prof Salam.
Salam.
Prof. Salam.
Sehat, Prof.
Alhamdulillah, Prof. Chandra.
Ada
Terima kasih, Prof.
Terima kasih
Pak
ya
Catur.
teman-teman semuanya. Prof. Chandra, sudah selesai acara kita.
Prof. Chandra.
Mbak Din. Terima kasih Mbak Din.
Alhamdulillah,
Prof.
Mbak
Salam.
Andri, tim Bella, terima kasih, Dokter Dwi, terima kasih.
Terima kasih ya, Mbak.
Sama-sama, terima kasih banyak.
Apakah ada bahan presentasinya? Ibu?
Oh, nanti di link, Bu.
Cara
Ya.
Di link sertifikat. Kalau itu
Ada di
di link
link.
langsung dikirim.
Oh iya.
Tapi yang
Cara
Prof
jadinya
Andrea,
nggak ada.
Thank you, Pak. Thank you very much.
Terima kasih.
Terima kasih Bapak Ibu.
Ya. Salam, bagaimana kabar? Sehat, Prof?
Alhamdulillah.
Alhamdulillah bisa
Teman-teman
gabung.
sehat-sehat semua ya.
Iya, Prof.
Cara jadinya mana?
Prof. Chandra.
Prof, terima kasih. Prof mengabarkan Dr. Dewi sudah seminar tesis minggu lalu, Prof. Alhamdulillah
gitu?
sudah selesai, iya.
Alhamdulillah.
Prof,
Saya besok nguji di UI. Ya
Oh,
lewat,
baik.
lewat Zoom.
Oh iya, baik, Prof. S3 ya, Prof ya, dokter.
Ya.
Oh iya, baik. Selamat ya, Prof. Mudah-mudahan sehat terus,
Terima
bisa
kasih.
bertemu lagi, insya Allah. Terima kasih sudah
teman-teman
join.
ya.
Baik, Prof. Salam.
Assalamualaikum.
Cara hadirnya ya, Pak.
Terima kasih.
Cara hadirnya sudah.
sudah ada, Pak, di link. Mungkin dikirimkan lagi panitia.
Cara hadirnya mana ya?
Oh iya, kami kirim lagi ya, Pak.
Kirim lagi linknya ya.
Halo, Mbak Yuniarti, data hadirnya belum. Data
Iya, Bu.
hadirnya.
Data hadir.
Kita kirim lagi, Pak. Kita taruh lagi di ini. Di chat.
Data hadirnya belum ada.
Iya, sebentar Pak. Sedang
Izin dikirimkan di dalam chat box Bapak.
Data hadirnya mana?
ya, sebentar.
Bisa ngirimkan lagi.
Oh, lagi. Ini tidak ada data hadirnya.
Iya, Pak.
Halo?
Ya, sebentar. Coba saya kirimkan.
Terima kasih.
Oh, dia ngomong ono kok. Oh, ini apa?
Kedua. Nanti sertifikat langsung ke sana ya, Pak, langsung dikirim ke emailnya setelah isi daftar hadir.
Terima kasih.
Ya, sama-sama, Mas Samsul. Alhamdulillah sudah selesai satu.
Lega.
Tinggal ngumpulin ringkasan nih, Tasya sudah ya, Tasya ringkasan. Saya sudah buat juga, nanti kita mix saja ya. Dikirim saja via grup ini aja, grup panitia ya.
Ada banyak.
Dokter Dwi, terima kasih ya sudah memeriahkan acara kita. Alhamdulillah lancar, Dokter Dwi.
Andri, Mbak Upi, selamat ya.
Iya. Mohon Mbak Din.
Lancar.
Jangan bosan ya Mbak Din. Mbak Endang, terima kasih. Keseruan di panitia heboh.
Bella, terima kasih ya Bel, jangan kapok ya Bel.
Assalamualaikum.
Ya.
Oh, namaku ada kok.
Assalamualaikum. Waalaikumsalam. Oke. Ya, panitia yang belum daftar, ayo daftar biar dapat sertifikat. Saya barusan juga daftar.
Bisanya lupa panitia.
Lupa.
Makasih Ibu.
Amin, Mbak Andri.
Ya,
Sudah selesai ya?
Sudah
Sudah Mbak Dini.
tinggal ngeberesin.
Beberes warung dulu.
Beres warung.
Ya, saya boleh izin live ya. Mau siap-siap
Ya,
nonton.
Mbak Din. Hatur nuhun ya Mbak Din.
Ya, sami-sami. Assalamualaikum.
Waalaikumsalam.
Bu, Dok, duluan ya.
Oh iya, makasih ya Bel.
Ya, makasih Bu.
Terima kasih banyak Bella.
Iya, Dok.
Keren deh ini berdua. Pokoknya bisa dijadikan
Panitia
duet
tetap.
lagi nih.
Kita kalau sekali jadi panitia besok kan langganan.
Jadi duet lagi ya.
Iya.
Regenerasi nih.
Bu, saya izin live ya.
Ya, baik Bel. Salam.
Terima kasih banyak Ibu, kami juga izin pamit.
Ya, makasih ya Dokter Dwi ya.
Terima kasih sudah dilibatkan.
Ya. Oke.
Terima kasih, sehat-sehat Ibu semua.
Ya, makasih.
Assalamualaikum.
Waalaikumsalam. Untuk acara pertemuan kita dengan Angkatan 2 dan 3 diundur Jumat depan, Jumat ini ya. Tidak jadi siang ini ya, karena masih belum kepegang nih kelihatannya.
Baik, Bu.
Iya.
Jamnya sama ya, Bu Ndaru?
Iya, jamnya di jam yang kosong ya. Di jam yang ada jam kosong nggak sih kita Jumat? Kalau jam 1 jamnya
kuliah.
Jamnya farmako itu kan fitofarmaka kan. Jam kedua ya kalau nggak salah jam 10.
Oh iya, jam 10 kosong.
Jam 10 kosong ya. Kita pakai di jam 10 ya. Untuk teman-teman yang sudah memiliki proposal, nggak apa-apa, silahkan disiapkan saja. Oke, ini masih ada 33 orang tamu, belum. Oke, ini Leoni. Kenapa Leoni?
Enggak benar. Tadi yang dipersiapkan proposalnya maksudnya bukan PowerPoint-nya atau gimana benar?
Ini aja judulnya ya, kemudian bisa cerita tentang apa gitu, apa yang ingin dikerjakan ya. Kalau proposal kalau PPT takutnya nanti waktunya banyak menyita ya, banyak menyita waktu ya. Paling enggak bicara singkat judul, kemudian apa yang ingin dilakukan ya. Kemudian dengan pembimbing yang sudah diajukan ya. Karena saya sih pengennya mahasiswa bisa ikut mengajukan hibah internal di sini gitu. Kan akan berakhir tanggal 1 November, tapi masih bisa lah insya Allah ada extend waktu ya, mudah-mudahan.
Baik, benar.
Kalau Leoni udah ini kan, sudah presentasi kan?
Belum benar ya? Untuk proposalnya.
Udah ngajukan hibah belum? Belum ya?
Udah bareng sama Bu Upi ya, Bu Upi ya.
Oh, oke. Ya, oke. Oke.
Izin pamit ya Bu Andri.
Udah ya, kita udahan nih.